morning, good afternoon. This is Ben Reese, ECS Marketing. I'm joined today by Srinivasrao Balaga of Lucid Motors. Balaga has actually done a lot of work with us over the years and has an extensive amount of experience in dimensional management. Balaga, do you mind telling us a little bit about yourself and your previous experience?
Well, Ben, yep. Thanks for inviting me for this interview session. I have dimensional management experience for over 15 years now, and using the 3DCS for a couple of years now, and since we got that tool back in my previous company. So I have the quality experience dealing with the suppliers, the fixtures, and in nutshell, it's the whole dimensional management. So right now I'm working with Lucid Motors as a senior dimensional lead engineer and leading the dimensional team here for the project, which everyone is waiting to get hands-on, which is Lucid Air. That's a brief about me. Yep.
Well, I know they're lucky to have you, with a full breadth of experience from, start to finish in dimensional management. I'm sure your expertise is appreciated. There aren't a lot of people with that level of experience right now. So I'm glad they were able to get a hold of you. And as part of all that, all the different projects you've done, is there one particular challenge or issue that you're especially proud of that you're able to resolve?
Yeah, I mean, I had many in my experience, to be frank, but if you're asking me a specific one, yeah, I can choose the best out of them. And then I would say when I was working in my previous company, which is I used to work more on suspension systems. So the DV of the suspension system, how hard it is because of the nature of the movement, the kinematic mechanisms all over the suspension. So we had a major issue, which is basically getting the bump steer to the specification defined by the design team. So we had a lot of variations from a vehicle to vehicle when they're trying to test it. So they really need to understand from where and why this variation in the bump steer is coming. So we used the 3DCS, which is very robust in terms of modeling the kinematic mechanisms, and I did able to get the variation, the root cause for the variation using that mechanical modeling using 3DCS software. So that's a major challenge, and it took time to understand what's the root cause, but the 3DCS tool is really helpful. Without that, we couldn't do it. That's a major one, which I personally feel I achieved in the past.
Yeah, we actually were lucky enough to have you join us at DCS for a little while and help us with some kinematics. You're quite an expert when it comes to mechanical assemblies, and I'll make sure that in the description below, I'm going to include a link to the webinar that you did with us on a suspension model. Now that was a little different. What was that one focused on?
The one which I did when I was there in the dimensional control systems, and the one which I did in the past, the previous company, it was like basically compliant modeling. So the previous one, what I used to deal with is pure kinematic, and there is no compliance considered for the bushers. So the one which I have did in the webinar, basically that consists of the bush compliance to understand how much it helps during the articulation through the range of motion.
That's right. Yeah. We combined our finite element analysis compliant modeler with the mechanical assembly. That's a lot. You got to have quite a machine to run those analyses, though, right?
Absolutely.
So when it comes to 3DCS, I know that you've done a lot of mechanical work. Is that the feature that you've prefer and you like most, or is there anything in particular that 3DCS offers that you like?
So when it comes to mechanisms, I prefer a mechanical module rather than using a normal mouse because it gives us pretty much about the envelope study and everything, which is a major setback for the designers to understand what is the variation to that envelope, because they do design the envelope to the nominal with an articulations, but they don't understand what's the variation at the extreme end. So I prefer mechanical when there is a mechanism.
Do you think that the use of joints and constraints is maybe more intuitive, especially, well, at least for new users?
The joints and constraints. So if you ask me which one you prefer, whether the joints and constraints are the mechanical ones, the joints and constraints need to understand the degrees of freedom to be dropped off, the sequence of the joining and everything. That needs a kind of expertise to understand the degrees of freedom and everything. But the mechanical ones, it drops the degrees of freedom by itself.
Gotcha. So it kind of helps you out a little bit.
Yeah.
Was there something that you found a little frustrating about using it that you think, you would have liked us to have improved for you, or that is on its way to being improved?
Yeah. So when I did a model back when I was working with your team, like we tried to analyze the difference between the joints and constraints and mechanical model. Are we going to get the same results? So it took a lot of debugging when we are trying to use the joints and constraints, because the sequence is very important, and dropping degrees of freedom and everything is very much important when as compared to the mechanical model. So it takes time. So the joints and constraints needs a lot of debugging and a lot of analysis by an individual.
Right, because I know that they are specifically set up in sequence one after another. So if you get something wrong with the sequence order, it can cause, especially if you have a lot of moves or a lot of joints and constraints in your model,
Right.
it can also be difficult and something to keep mind of. We actually have some best practice videos that are very helpful in laying that out for new users. So that's something, if you plan on using mechanical, might be, you obviously have made some of those for us. So that's where many of them are coming from.
Absolutely. So if a user wants to use joints and constraints, which is pretty much easier because the designers uses the joints and constraints when they try to assemble the parts in the CAD. So and on top of that, if the dimensional engineer was trying to do the DVS tags using that 3D model, it's good to have that the guide which we have prepared, the guidelines. So if he follows that, probably that saves time and a lot of debugging time.
So when it comes to the value of using the software, because obviously if people weren't getting a high value out of it, they wouldn't be using it. Can you tell me a little bit about the kind of value that you have found by using 3DCS?
Yeah, I've been, as a tool, I've been working on this dimensional management for 15 years, and I have seen a lot of tools, but I felt that 3DCS is more robust and much more user friendly, and it got a lot of optimization and kind of using customized macros, the user DLLs, which is pretty good option for 3DCS instead of just limited to a couple of modes. It's good to have always the customized user DLL, so that makes the software more robust and user friendly. And not the least, but the good thing of what I found with the 3DCS is the integration into the 3D CAD platform, which makes this a unique one, and I prefer that, instead of converting all the CAD into a different format and then dumping that into another software tool takes a lot of time. So I prefer 3DCS, which is integrated, and I love it.
So there's something in the tool set that helps it stand out to you as opposed to other tools on the market?
Yeah. So when you say standout, it's basically the customization, which I feel the best option than the rest of the tools, and the way it's it's been used. I mean, like the GUI, the user interface, and everything is user friendly. So that's what I feel it's good than the rest of the tools.
Yeah, I can understand, especially with the amount of different kinds of applications you've done, the ability to, customize it or tweak it for specific scenarios, I could see as being very helpful. No tool out of the box can work on every single scenario that could possibly occur in manufacturing. So that ability to slightly adjust it based on what you need. We actually have another presentation that's specifically about a custom built measurement for a special scenario. So I can definitely see how that could be a helpful feature.
Right. Absolutely.
So speaking of those kind of applications in business, how differently are you using this tool in your current company at Lucid? Did you find any major advancements or anything that really helped lend from your previous experience?
Okay. So the major advancement, I would rather say that the use of the complaint modeling, because the Lucid is an EV company and they are always covering for the weight, so they need to shred up all the weight, meet the weight target. So then we need to deal with the parts which are lighter, so they are flexible. So we need to have sort of a complaint model which considers the stiffness of the parts on top of the tolerances what we mentioned. So sometimes we don't understand what's happening if we just do the straight stacks without the stiffness. So it's very good tool we've been using, and it helped us a lot to root cause some of the dimensional issues which we faced. So
I don't know if you can answer this, does thermal come up in that too much? I've heard from my discussions with other EV companies, especially working with large battery packs or, with any kind of, system, thermal can always be a concern. Is that something that you can speak to briefly, or?
yeah, so well, I haven't used thermal, but because I've been doing most of the work for the suspension and the body structures. So, and we're not using any thermal process to assemble the parts. So it's only a compliant process.
Well, there's still working with all of the compliant components. I know when a lot of automotive companies move to aluminum in order to lighten, the material itself responds completely differently to assembly processes than sheet metal. So whenever you're using any kind of new composites or material, it's not going to respond the same to the sheet metal. And it sounds like that's what you're talking about simulating is, making sure the material properties are included. Great.
Exactly.
Do you
So
have
apart from that, I also find what different we are doing is getting the plan data and doing a kind of a selective assembly during the proto development stage. So we get the plan data like a 10-piece study, and then we input that into 3ds Follow and then see what happens with the selective assembly and what kind of variations we get it. So using the CMM dev DLL, which is a very helpful tool, we are using that.
And is that, would you say that's early in the design process, like during prototyping, or is that?
Yep. It's in prototyping. Yeah.
Fantastic. Gave you some early ideas of where you might have issues and where you can focus your studies, right?
Exactly. Yep.
Yeah, it's hard to do an analysis on every single gap and every single flush in the entire vehicle. So,
Yeah.
understandable. So here's something. Do you have a particular story or anecdote about an issue that had a strange reason or an odd source? Say something that might have been either not completely dimensional or from like an assembly process that you could share with us, maybe from your previous experience?
Um, We had plenty, but if you ask me, which is a challenging one, so it happened to be like the way the initial designers select the locators, which
Mm,
created stacking the tolerances. So no one really could understand why this is happening and why we're not able to minimize the variation on assembly level. So in the past, I used the locator sensitivity analysis, which helped us, to showcase that the optimized locator should be, placed here in the pod, and then at the assembly level, we get the minimized, stacks, tolerance stacks. So
mm,
that was a major challenge, and we couldn't figure out why this is happening. And that's a standard practice people used to get, on a single piece. This is four-way and a two-way, and then we start using assembling the parts, and all the parts are in spec, but though the assembly requirements, we're not able to meet it. So in the previous company, I had that issue, and we used the locator sensitivity analysis, which helped us a lot.
that's great. Yeah, it's just how you locate your parts can change a lot, even if your parts are all good, right?
Yes, absolutely.
Fantastic. Well, thank you so much, Balaga, for joining me today. I really appreciate it. And I know all of our attendees at the DCS Global Technology Conference will be happy to hear about your experience and insight into dimensional management.
Thanks, Ben. Thanks for inviting me.
All right, great.